Isolation as a force of evolution. Isolation has a negative connotation, stressing involuntary detachment from others. In biology, however, isolation can be a force of change, a driver of evolution. To understand how, we must take a trip back to the early 1830s, when Charles Darwin sailed around the world aboard the HMS Beagle. One of the stops on the voyage was an archipelago known as the Galapagos Islands. As he explored the islands, he collected specimens of a number of birds that had similar body shapes but very different beaks. Back in England, in 1837, Darwin consulted ornithologist John Gould, who told him that the birds were all different but closely related species of finch. This was the clue that unlocked Darwin's now famous theory of evolution by natural selection. His thought exercise went like this. 3 million years ago, lava spewed out across the ocean floor and accumulated into cone-shaped landmasses. The Galapagos Islands were born. Then, about 2 million years ago, a small flock of birds from mainland South America, known as dull-colored grassquits, made its way to the islands. Isolated from the mainland and exposed to a unique set of environmental conditions, the grassquit population began to change slowly, adapting to the various habitats on the islands, until different groups of birds became different from each other and from birds on the mainland. Biologists today refer to this type of speciation as allopatry. Populations that are completely separated by a physical barrier and eventually become distinct species that can no longer interbreed. Other types of isolation can lead to speciation. Reproductive isolation is also possible. In the Baltic Sea, 2 types of flounders can be found. The Baltic flounder and the European flounder. They look identical physically, but they do not interbreed. The Baltic flounder only spawns in shallower, less salty water. The European flounder only spawns in deeper water with greater salinity. Biologists now believe these 2 fish are distinct species that diverged from a common ancestor about 8,000 years ago, shortly after the Baltic Sea formed. So, while we often think of isolation as a negative force, in biology, it's a force that has helped to create the wondrous diversity of our planet.